Alright, so on this one we only have one trig function. It's just the sine x function. So there's no like terms to group. We don't need to use a double angle identity substitution because we already have just sine x, and our whole goal is to get sine of something equals a number, right? And then we can figure out what angle this has to be, and that's our answer. So what we're going to do is just add root 3 to both sides, and then that gives us 2 sine 2x equals root 3. Divide both sides by 2, which gives us this. And now we need the angle. What angle do I plug into the sine function that gives me root 3 over 2? Well, root 3 over 2 is the taller as opposed to a half. So it's going to be these reference angles. These are where our heights are root 3 over 2, and sines are our y's, so our heights. And we want them to be positive, so it's this one and this one. So that's going to be a 60-degree reference angle, or a pi over 3. And then this is a 180 minus 60, or a 120-degree reference angle, or 3/3 minus a third is 2/3 pi. So I'm going to do this in radians first, then I'll do the degrees after, for those of you that are just radian-phobic here. So this angle we need to plug in an angle that gives us root 3 over 2. And we just said that that angle must be either pi over 3 or some multiple of pi over 3. Not multiple of pi over 3, but rather 2 pi over 3 plus a full circle, right? Because we can go pi over 3 plus a full circle and end up with another pi over 3, or end up at the same spot. Or if you think of it this way, we know our sine function typically does this. Well, sort of. Now it's going to do this. So that height, where it obtains a root 3 over 3, is going to happen 4 times. Here, 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 and here. All right, this picture isn't necessary for you to solve the problem, but that's an important idea. It's good to have that idea in your brain case there. So we have this answer, or any integral multiple of 2 pi, and we also have 2x has to equal 2/3 pi plus some multiple of 2 pi. Now I'm going to solve these equations, and I divide by 2, divide by 2, divide by 2, right? Because I'm solving for x, so I'm going to divide by 2 for all of these. And that gives me x equals pi over 3 times 1/2, or pi over 3 divided by 2 is pi over 6, plus, now it's 2 over 2 pi, some multiple of pi. And I'm going to keep adding multiples of pi until I get outside my range, and then I'm going to stop, because x has to be between 0 and 2 pi. And then over here we've got the x equals 2/6 pi plus multiples of pi. Or we could write that as x has to equal pi over 3 plus multiples of pi. Now, to make the algebra, or like the number crunching easier, especially for those that you don't do fractions, I'm not going to think of this as adding pi a bunch of times. I'm going to think of adding 6/6 pi. And here I'm not going to add pi, I'm going to add 3/3 pi, so it makes it a lot easier. So now I have x equals pi over 6 plus 0. Pi over 6 plus 6/6 is 7/6 pi. And if I added another 6 pi, or 6 over 6 pi, that would give me 13 over 6 pi. But that is more than 2 pi, right? Because 2 pi would be 12 over 6. So we don't need this. These are our answers here. And then this is going to give us x equals pi over 3 plus 0. Pi over 3 plus 3/3, which is 4/3 pi. And I'm done, because anything else puts us outside our domain here.